Good evening and thanks for joining us for the AI for Accessible Education webinar, on which we're set to discuss the application of AI to education, with particular focus on increasing both access and tailored content to meet the needs of those worldwide. Tonight we have three speakers, Vinod from Coursera, Kian from Stanford University, and Sergey from Gradescope. Will be presenting their work and slides with time after all the talks for some question and answers. Questions can be submitted via the Q&A section below, and then we'll select a few alongside those pre-submitted for the speakers to answer after their talks. Throughout the webinar, there'll be polls made available, so make sure to get your votes in, as we like to keep this as interactive as possible. And I also want to quickly remind you that this is the second in our AI for Good webinar series, which in the coming weeks will see topics including AI for crisis prediction, AI for climate change, and more. So make sure to check those out and join us if you're interested. Finally, if you run into any technical difficulties, you can contact my colleagues either on the live chat function of our website or via email. As you can see on the screen here, you can email my colleague John, who's accessible on john@rework.co. So if you have any technical difficulties or any questions outside of the webinar, let John know and he'll be happy to help. Also, post-webinar, or if you have any other questions for me, you can get to me on luke@rework.co. So without further ado, I'd like to introduce our first speaker, Sergey, co-founder and CTO of Gradescope, who is presenting on AI assistance for grading handwritten free responses. Sergey's goal is to develop and deploy AI systems to improve human life. In 2014, he finished his PhD in computer science at UC Berkeley and co-founded Gradescope, which is an AI-assisted platform for instructors to grade exams, homework, programming projects, and labs. In 2018, Gradescope was acquired by Turnitin, where Sergey now heads development for AI and STEM. Sergey, over to you.
Thank you. So I'll share my screen.
Brilliant.
All right, thanks for joining. I'll be talking about AI assistance for grading handwritten responses and see if there's a, okay, 10:05. So I have until 10:15 for the presentation, and then 5 minutes for questions. That's right.
Sure.
So briefly about me. Right now I work as head of AI for STEM, science, technology, engineering, math, at the edtech company Turnitin. Turnitin is one of the biggest education technology companies. We have served 35 million students in over 150 different countries. I think in the UK, we have like 95% higher ed penetration, over 1 billion paper submissions. And Turnitin is mostly for essays to be turned in and checked for originality in different ways, and then also to provide grading tools to instructors. I came to Turnitin because they acquired a company that I co-founded called Gradescope, which started as a TA side project and expanded to be a company. And today we have over 200 million answers graded by over 20,000 different instructors at many, many different schools around the world. I'm also a co-organizer of a program for full stack deep learning. So it's a program that has weekend boot camps. And I'm also teaching the University of Washington Professional Master's course in full stack deep learning. And before that, I was finished a PhD at Berkeley in computer science, where I was doing research in computer vision mostly. So how Gradescope got started is I and a few other people were TAs of this course called Introduction to Artificial Intelligence, which is actually a very popular course. You can check it out. It's ai.berkeley.edu. A lot of high schools use it, or secondary schools around the world use the materials. And obviously it's teaching a very advanced subject, artificial intelligence. But in order to assess our students, and at the time I was teaching, it was maybe 200 students. And today it's at like 800 students per course. So it's really blown up, just like all computer science courses. To assess them, we still had to grade on paper for reasons of you don't want people's phones or computers out in class because of potential for cheating and because of Wi-Fi problems, actually. And you also don't want to ask only multiple choice questions because you want students to show complicated work and write math and so on. So what you end up with is a stack of papers, and you really spend a long time grading it. So here's a PhD comic where the punchline is, grading. If only you cared a little less, it would take less time. But to actually accurately assess people just takes a painfully long time. It's also hard to be consistent when you grade on paper. So maybe if, sometimes you take 2 points off for a mistake, and sometimes you end up taking 5 points off for the same mistake. Or if multiple people are grading the same question, they might disagree as to what, how much to take off. The student, because it takes so long to grade and because it's paper, so they have to wait until like the next class section to pick up the graded work, they often forget what the test was even about. So the feedback to the student is delayed and kind of prevents learning. And then also oftentimes there's no insight when the student gets the grade and they just get a grade or a score, 70 out of 100. It's not at all clear to them why they missed points or how they can improve, like what they can actually take away from the feedback that the instructor is trying to provide. So that was a very frustrating system, and being computer scientists, we decided to try to make it better. So the simple thing we came up with is just scanning the papers in, and then instead of grading on paper, we could build a web interface where you would see the scanned page, or better yet, just the region of the question that you're grading. And then you can build up a rubric as you grade. And this is how it works. So this is a little video that I'll let play out. As you read the answer on the left, if it's not already reflected in the rubric, you can add a rubric point. As you apply different rubric items, it grades the answer. And as you change the point value of a rubric item, it retroactively applies it to all of the answers that have been graded with that rubric item. So I'm just going to let it play one more time because it's a lot to take in. But the core idea is very simple. It's just you see the student work on the left, and you have a modifiable rubric that's shared among all the graders on the right. This is also, the rubric also serves as feedback to the student, because when they get their work back, they can see exactly why they lost some points. And the next idea that we had is to use a little bit of machine learning to try to speed this up further. And so AI-assisted grouping is the first version of using AI for grading that we have. And the core idea is that if we can analyze what the student actually wrote, then we can put all of the answers that are saying the same thing into one group. And in that group, the instructor can then decide how to grade it. Is it fully correct, or does it deserve partial credit, or is it fully incorrect? So this is called AI-assisted grouping. Groups are formed based on the exact answer content. And the user interface looks like this. We actually took great care to make a user interface that was amenable to instructors being able to correct mistakes and merge groups and kind of make it their own. So it's not that the AI is really grading for them. It's really just an assistance that they can override, and they can check the work, and they're in full control of it. Because we form groups just on the exact answer content, we're only able to support some limited number of questions. So that's multiple choice questions and fill in the blank questions. So that's something where there's kind of a predefined area and the student writes only a few words at most. And then the other limitation is that when you have a group, you have to grade it the same way. Like all the submissions in that group have to be graded the same way. That's what the speed up comes from. And it's a huge speed up. So just going from paper to Gradescope, we observed like a 2x speed up in surveys of instructors. And this is a further speed up because oftentimes you end up with one group that has, 80% of all the answers were just the correct answer because most people got it right. So you can finish 80% of your grading in like one click if you have a group instead of seeing the same answer over and over again. But, these limitations are pretty stringent. And so we had a question like, well, what are instructors actually grading, right? Is it mostly multiple choice, or is it mostly fill in the blank, or is it something else? So what we did is we built an interface, and this is in collaboration with some Berkeley professors, Marty Hurst and Paul Laskowski. We annotated 25,000 questions using this custom-built interface, and we published results about it. I have a link here. You can go to my website, sergeykarayev.com, for the link. But what we found is that there's several question types. So there's kind of binary multiple choice questions. There's multiple choice questions where multiple things be selected, kind of select all. There's the fill in the blank questions, which are here called short writing. And there's a lot of those. But there's also a lot of medium writing and long writing questions. So that's questions where the student has to write either a sentence or two, or potentially even a couple of paragraphs, or have to show a lot of math work that they're doing. So we call those medium writing and long writing. And additionally, there's kind of drawing questions. So these are actually questions in our data set, medium writing and long writing, but we're not currently able to assist the users with AI to grade them. So the first question, this is something we do. So the first question we have is, well, what's the right user interface for AI assistance for these short answers? Is it the same as we have now for fill in the blank questions? Is it grouping answers? The answer we came up with is no, because the answers for the short answers are too high dimensional. There's kind of too many different ways to say a thing. They can differ in ways that might be important. The rubric is not mutually exclusive. So maybe what you want to do is you find all the answers that mentioned a certain fact and you give them a point. And then some of those answers mention another fact, but not all of them. So you want to give those another point. So grouping is just not the right interface. What about searching? So if I can just kind of type some text like neighbor and tie, I can find all the answers that mention that, and then I can quickly grade all of them with a rubric item or two, and then I can search for another thing and grade those. So we built a UX prototype. I'm pixelating the student answers to preserve privacy. And the UX prototype is very promising, but we're working on it, but this is not really AI, so I'm not going to talk about it here. What about sorting answers? So that is an interesting idea. And what we did is we analyzed 230,000 graded short answer questions, or answers, I should rather say. This is work under submission to a conference. So we analyzed how long it actually took to grade each answer. And what we found is that if an instructor sees a sequence of similar answers, they actually speed up the grading. So on this chart right here, if they've seen 0 similar answers, so they just started grading, or they were getting an answer and then they a different answer, it takes them 2 seconds to grade that answer. That's on the left of the chart here. But on the extreme right of the chart is a case where they've seen 6 or more answers that are all similar. And by the time you see 6 answers that are all similar, you just kind of primed to grade it in a certain way. And so the grading speed speeds up from like 22 seconds on average to about 13 seconds on average. And so this is actually another 2x savings that would be awesome to get. So this is what we're working on right now. Now, if we want to develop AI assistance for sorting these short answers, there's 3 sources of complexity that we have. The first complexity comes from the fact that it's handwritten. The second is that it's, let's say we can understand the handwriting, but what is the answer actually saying, like the semantic meaning of the words. And the third complexity is the rubric that the instructor is trying to grade on. So some rubrics are just correct or not correct, and some rubrics are very detailed. And the sorting is actually going to have to be different for those cases. So first, I'll talk about handwriting complexity. So handwriting is like famously hard in general. Here's an article I found from the United Arab Emirates saying, over 7,000 deaths per year are because physician handwriting is indecipherable a lot of the time. But in STEM education, there's additional complexity. There's diagrams that the student can write as kind of part of their answer. There's math and science notation that's interspersed with words. So you have to deal with fractions and special symbols, subscript, superscript. There's code, which is very important to get exactly right every character. A lot of handwriting recognition has a language model on top of it that basically corrects mistakes. But if you do that for code, it doesn't do the right thing. You kind of want the underscores and the exact characters. And then you have stuff like arrows and crossouts. So a student might write something, cross it out, Or a student might write an answer and then write another answer and put an arrow into the first answer. And so following those arrows is actually quite complicated. So we had an annotated set of paragraphs and we checked out different handwriting OCR APIs. There's one from Google, one from Microsoft, and a couple other ones. Microsoft had the best performance, but it still had a 17% character error rate, which is quite high. Our old in-house solution that we currently have for the fill in the blank questions, which is based on a convolutional net followed by an LSTM, was even worse than that. And it works by finding lines and then recognizing all text within a line. So we're building a new in-house solution, which is a convolutional net followed by a transformer architecture. And that is better than Microsoft already, and we're still improving it. It's trained on millions of handwriting-like synthetic examples. So it also works for printed text, not just handwritten text. And it runs on whole images using attention to read line by line instead of finding lines first and then reading within a line. And it reads paragraph by paragraph. And it's even able to kind of follow arrows and understand insertions and deletions and stuff like that. So it's very exciting to see that come online. If we solve the handwriting complexity, we're still left with answer complexity. And that's basically like the NLP foundational problem of there being an infinite number of ways to say the same thing. For grading specifically, length of the answer matters for grading time. And there might be interesting things we can do with that by presenting, just presenting short answers earlier or later, just to kind of like keep the grader in flow. And this is data that we actually can see in our data set is, measuring the number of tokens in the answer versus the grading time. You can see a clear correlation. It's quite interesting. And then the last thing is rubric complexity. So like I said, some rubrics are detailed where the instructor might delineate all the possible ways to be wrong, right? Or all the different ways to accrue points. Or it might be very coarse, just like correct, incorrect, or maybe just correct, partial credit, incorrect. Obviously, the detailed rubric gives us a lot more information for how to sort because we just receive more information about what's different or similar. But the coarse rubric, if we can just find all the correct answers and put them up front, that would probably speed the instructor up. And maybe we can use other measures of text similarity in that case because we don't have the rubric to fall back on. And also interestingly, the more items the rubric has, the longer it takes to grade, which is also something that we see in the data. And the difference is quite stark. So if you have a rubric that's just correct, incorrect of size 2, on average, it takes 11 seconds to grade an answer. But if you have a rubric with over items, on average, it takes like 23 or 24 seconds to grade an answer, so more than twice as long. So why do we do all this? Just to summarize, our goal is to reduce the time that instructors spend grading. Grading is a mechanical and kind of thankless task that if you could just do it faster, you lose out on anything. But what you would be able to do is spend time with something that's really the crucial bottleneck, like the 2 sigma to education is paying personal attention to each student and being able to spend time with them, answer their questions. Every minute spent grading is a minute not being able to spend interacting with the student. And also because everything is digitized using this Gradescope interface, we can surface up insights into student learning or maybe even the quality of your teaching. So that's it for me. Happy to answer a lot of questions, but I just wanted to keep it short.
Yeah, great. Thanks for that, Sergey. So we've got a couple of questions. So the first one, how does the grading help with data-driven insight?
How does the grading help with what?
Data-driven insights.
So just the last thing I said, I guess, to expand on that, imagine being able to see the reason why people lost points on an assignment. So let's imagine you're an instructor and you have 100 students in your class, you give an exam, and the average score on the exam is 70 out of 100. Is that because, every student got 70 out of 100? Is it because some students got perfect scores, some students got very low scores? did a lot of students miss one question, which might mean that you didn't teach the concept that that question is trying to cover well enough because everyone missed it? Or is it the case that there's a cluster of students that all missed all the points that had to do with a certain concept, right? And maybe you can actually see that those students are all in one section, and that section just didn't happen to cover that concept at all. So that's what I mean by insights. Like, if we have the detailed reasons for every point, for every student on every assignment, there's a lot we can do to understand why they're losing points, and then we can do a lot to remedy that. We don't currently have anything in production that does that beyond just a simple kind of statistical histogram overview and the ability to tag questions, but we don't surface up any insights right now.
Sure. And just another quick question. Obviously, there have been some really good ones come in, but we'll cover more at the end if possible. So there's another one. Vania asks, how long does it take to digitize the papers? What tools are used? And would these be made available to schools as a whole?
Yeah, so this is quite, so like a lot of you are probably under shelter-in-place lockdowns due to the coronavirus situation, and a lot of schools are closed and students are learning from home. There's a huge demand for being able to assess students at, in a quality way when they're at home. So Gradescope can assist with that because the students can actually submit their own work that they did on paper with their mobile device just by taking pictures of it and then submitting to the website. We also have support for online assignments, which obviously now you can't draw diagrams and do stuff like that, but you can type out your answer. And so that's another way. But the first use case that we had is in the classroom, instructors would gather the papers from the students, walk over to the departmental scanner and scan a big stack of papers in, upload the file to Gradescope. So that's how we started, but now people can use mobile phones or even online assignment submission.
Okay, great. Well, thanks for those. We'll cover some of the other questions, like I say, at the end that have come in. But without further ado, I just wanted to say thanks to Sergey.
Thank you.
Next up, we've got Kian from Stanford University, also representing Wakira. So Kian is a technology entrepreneur and lecturer at Stanford University, where he teaches deep learning in the computer science department with Professor Andrew Ng. He is the founder of Wakira, a company that measures the skills of data scientists, machine learning engineers, and software engineers, and serves them career opportunities. Kian is also a founding member of Deep Learning AI and co-created the deep learning specialization course on Coursera with Andrew Ng. So not to delay any further, over to you, Kian, if you want to share your slides.
Thank you very much, and glad to be here. I have to say that I want to use this opportunity to thank Sergey. I'm a happy Gradescope customer for the past 2 years, and Gradescope has helped us grade thousands of students since then. So thank you for that. Yeah, I'd like to start by sharing my screen, if you don't mind, and please let me know on the chat if you can see my screen or not, since I'll be presenting on Keynote.
Yep, we can see that.
Okay. Are you seeing the screen with the full slide?
Seeing the presenter notes as well.
Okay. So let me try to modify this. Up. How's it now?
Yeah, perfect.
Okay. So excited to be here, and thank you for inviting. I like to start in general with having everyone on the Zoom chat tell us a little bit about something fun they did over the weekend in order to make it as much interactive as possible. So would people mind commenting on the chat and letting us know what they did over the weekend? I'll get started. I don't think I can comment, but had to set assignment, Gordon. Okay. Gradescope should be helpful. Yeah. Okay, thank you, Vanya. What's Ozark? Ozark, I bet. Ari. Okay. Cool. I think it's a way for us to get used to the chat, and then please feel free to use the chat during the discussion. So my goal today is to talk about mentorship and careers, and as you may know, online learning democratized access to education, so you can learn from anywhere. But mentorship is still a very scarce resource, especially in data science and machine learning, where the number of mentors per learners is very low. In order to give access to mentorship at scale, we need to break the problem into pieces, and that's what I want to talk about today. So here is a simple framework for mentorship. If you are talking to a mentor, she might tell you, or she might try to figure out, where are you at right now in your career? And then B, where do you want to go aspirationally, but also where you can go? And then using A and B, she should be able to design and recommend a path P for you. So in this lecture, I'll refer to these 3 steps, which are going to make up our outline in terms of evaluation of your current skills, estimation of where you want to go, where you can go, and recommendation of a career path. And we'll get started with evaluation, where I'll talk about how to build a scalable self-assessment for the field of AI. First, in order to build a self-assessment, you need to understand what the job tasks are. In other words, understand what people are doing, what machine learning engineers are doing and data scientists are doing, since we're in the vertical of AI roles. And so we went outside with my team at Coursera and surveyed more than 100 AI organizations. Our findings are summarized in the next few slides, and it starts with 2 types of organizations that stand out. First, data science organization that help a firm's leader make scientific or data-driven decisions to run their businesses more effectively. And team members in these organizations typically collect data, analyze data set, and suggest hypotheses and action. So we already see a little bit of the tasks that they carry out. And on the other side, we have machine learning organization whose goal is not to make scientific or data-driven decisions, it's to automate tasks. And the output is the automation itself that is achieved by a series of tasks that includes collecting data, training models, and deploying them. And so we tried to templatize that in order to build a scalable system. And we came up with this AI project development lifecycle that is presented on this slide, where teams actually perform a series of tasks in order to engineer the data, pre-process it, and then make it available to use for the modeling tasks, which are preparing the model and training it. The deployment series of tasks come after the model has been trained and make it available to user, while the business analysis tasks are the set of tasks that analyze the model into production and estimate if it's bringing anything to the business bottom line. There is also a series of tasks under AI infrastructure that make this cycle as efficient as possible, allowing different tasks to communicate with each other. So you might have seen something similar, you might have seen something different. This is a summary of our findings from 100 AI organizations. And I'm actually curious to talk about each of these tasks. And if you can comment on the chat, it'd be really cool. What are examples of data engineering tasks that you see? If you're a data scientist or a machine learning engineer or an analyst or software engineer, typically. Either try. Okay, I'll go ahead then if people don't have lots of ideas here. So you will find tasks such as collecting data, defining data requirements, labeling, inspecting, augmenting, moving data, querying data, and tracing. And what we can do in parallel is, on the 3rd column of this table, try to identify what are the skills that are needed to carry out those tasks, and typically the skills area. This includes machine learning, as you can see, software engineering, and also some algorithmic coding for these data engineering tasks. And then we did the same thing for each of the other tasks of the AI project development lifecycle, coming up with all the tasks that are involved in modeling, but also involved in deployment, in business analysis, and finally in AI infrastructure. And tried always to map it to the skills, because our next step is to determine the skills that are needed to achieve those tasks. And so here, I'm going to simplify drastically, but you can think of it as running a clustering algorithm like k-means on the previously collected data. And the output is that 6 areas stand out, and they're presented on this slide. Most areas apply to more than one tasks, although some contribute to a primary task. As an example, the machine learning, deep learning, mathematics, and data science skills are typically the skills you leverage in modeling, while the software engineering skills are very important for data engineering, AI infrastructure, and deployment tasks. So now that we have the areas and the job tasks, it's time to write the assessment. And here, for the sake of time, I'm going to simplify again, but in order to write an assessment, you want to start with a grading rubric so that you know what you're assessing. So here is an example of a grading rubric for a machine learning test. In order to evaluate people, we need to write a computerized adaptive test that will follow this grading rubric that includes understanding machine learning models, understanding how to train them, and also structuring your machine learning project with a little bit of decision making involved that matters for these AI projects. Then we write questions, and each question evaluates a specific skills and has to clear a checklist. Also pass a QA process that is meant to enhance the test validity in order to ensure that we're evaluating the skills accurately and fairly. So here is what we see about evaluation. And now that we're able to evaluate someone at scale with the computerized adaptive tests and items, we want to identify what are the existing career tracks. And one thing that is interesting is that nobody has the skills or the bandwidth to carry out all the tasks of the AI project development lifecycle. So what are different career options that people can specialize in? To determine this, we've looked back at the software industry, where engineering teams have figured out how to split their teams and form their teams. And typically in an software engineering team, you will find back-end engineers, you will find front-end engineers, and we know what's the difference between these two. You will find deployment engineers, DevOps engineers, site reliability engineers, QA engineers, mobile engineers, many more. You tell me. But there is no equivalent for the AI team yet. So roles are not as well defined and understood. So we use this survey to understand what are the typical teams made of. And we found 5 roles that stood out and are differentiated by the tasks they carry out. So here you see that in the AI organization we surveyed, we found that data scientists differ from machine learning engineer in the tasks that they carry out, and specifically in the fact that the machine learning engineer has the ability to deploy and write production code, while the data scientist mostly prototypes code and runs business analysis. So it requires a certain level of business acumen. These roles, of course, have a different skill set that is detailed in our AI career pathways report that you can find on workera.ai. And we provide insights on what are the skill levels and the skills themselves that these different career tracks require. Finally, once we're able to evaluate and estimate our goal, it's time to recommend automatically a journey. And here our goal is to provide access to mentorship at scale, just as online education has provided access to education at scale. And to do that, we would need to build an actionable feedback and recommendation system, leveraging the understanding of A and B. And this can be at several levels. It can be at a skill level, so recommending a specific content, very accurate, and that's what our users like the most. Understanding the curse of dimensionality in k-nearest neighbor is a very specific skill under machine learning, and there is content in order to understand this better. So it's not recommending a course, it's recommending usually an article or a portion of a video. Moving forward a little higher level with course recommendations, where here we can recommend a learning calendar depending on someone's skill set. So for example, a typical transition is learning Python, learning machine learning, learning deep learning, and recommending specific courses in that case with evaluations and re-evaluations regularly to validate learning outcomes. Finally, recommending career track. So depending on the performance of a person on the computerized adaptive tests, they will need or might need to review a certain area, machine learning in this case. But they are job ready in many of those areas. And of course, job ready depends on the job. So we'll get to it in the next slide. But we're able to recommend career tracks and mix it with the aspiration of the person, so that a person can compare themselves to a broader community by getting access to their personal rank, to their percentile rank, but also strategize their learning in order to achieve a successful career transition. And finally, we have also recommendations at a job level, because many people in the AI community are looking for jobs and want to be able to compare themselves to the requirements of hiring managers. And so here we allow them to have a way to compare themselves, and also request a referral if their test scores meet the requirements from a hiring manager. I'll be ending the presentation on this note, and wanted to thank everyone for participating. Thank you.
Great, thanks, Kian. So we've got one question here, and obviously I'm sure others will come in that we can answer after all the talks. Someone's asked, what is the responsibility of public sectors versus private sectors and startups of ensuring we integrate AI into education?
So I don't know who asked the question, but could you expand on integrating AI? Are you talking about AI as a technology into education, or are you talking about AI as a field of learning? AI as a technology into education. So I can speak for the computerized adaptive testing, which include a machine learning portion, not for the broader AI technology. And I think Sergey and Vinod will have also good pointers on that. For assessments, typically educational institutions are starting to use computerized adaptive tests. It's really early stage. I think that there is going to be a massive change in the way people evaluate students, but also performances in companies. I think as a technology, AI can help accurately, or more accurately than we are doing it now, evaluate a person's skill, both to measure their performances against others, but most importantly, for them to self-assess themselves and strategize their career.
Sure, and another one, Yasaman asked, so Coursera essentially works as a bit of a mentor, first evaluating, then giving recommendations. Is that kind of how you see it?
Yes, I think it's you can think of it as a mentor that is powered by the computerized adaptive tests. So the idea is once you're able to self-assess yourself accurately, you get access to plenty of opportunities to strategize your career, be it from a skills upskilling perspective or from finding a job perspective. Thank you for the question, Jess.
Okay, brilliant. Make sure to get any other questions in for Kian. Obviously we'll move on now, but we can get to them after the talk. But up next, we've got Vinod, who's a data scientist working with the content strategy and enterprise team at Coursera, where his work has recently focused on developing ways to measure the learning outcomes of taking Coursera classes, especially in the context of company-sponsored training. So over to you, Vinod, if you want to share your screen.
There, I think hopefully everyone can hear me and can see my screen. And thank you all for attending the webinar. I should say that Coursera works directly with deep learning as they create, high quality AI content. And we also use Turnitin to support our online degree learners. So thank you both to Sergey and Kian for all your work there. I kind of wanted to talk today about kind of technology we created called Course Match, where the idea is we use what are called word embeddings to help scale online access to education. And this is kind of especially crucial during this, COVID coronavirus, as people are sort of sheltered in place and schools are shut down across the world. And for those who aren't familiar, I want to start with a little bit about Coursera. So Coursera is an online platform for higher education. We work with universities and companies around the world to take their content and put it online on our platform to be available to everyone. We have about 50 million learners today. It's sort of every country around the world. We have over 3,500 courses across a wide variety of subject areas. So this could be anything from data science and AI content to even arts and humanities content in English and art history. And then we work with over 170 university and industry partners to kind of create this content as well. And I wanted to start with a little bit of a snapshot on the impact of coronavirus around the world in terms of schools. So these are statistics from UNESCO. And kind of as we've seen today, as of May 11th, there's been 162 countrywide closures of schools. And that's 162 countrywide closures, but obviously there's a lot of countries where they've closed some schools and not others. And that in all leads to about 1.2 billion affected students who have had their studies interrupted. And that's about 70% of total enrolled learners. So it's just a huge disruption to the world of education, and people are scrambling to figure out how to teach online, how to migrate existing content online, how to support students in doing their assignments and doing their homework and attending lectures. And a lot of these universities don't actually have the online infrastructure built out to fully support their students. And so they're looking for kind of assistance and supplements they can leverage that have already been built out. And at Coursera, one of the things we created to try to help with this is what we're calling Course Match. And at a high level, what Course Match is, it's a machine learning algorithm. And what we do is we ingest the school's on-campus catalog. And then for each of their courses in their on-campus catalog, we match them to the closest Coursera equivalent, so we can serve our courses as substitutes for their in-person offerings. And to date, we've matched around 1,800 schools' catalogs with over 2.5 million schools' courses matched to date. And this was really pioneered by my colleagues Marian and Omar, so I want to give them a shout out for all their hard work here. And what I want to do now is kind of give you an overview of what this product looks like. So it exists as a URL that you can kind of go to. It's publicly available. And then once you go there, it doesn't seem to be playing. I don't know that I can play the video. Oh, there we go. So the way it works is you can go to the website and sort of enter in your university's name, and then we'll display kind of all the on-campus courses and the kind of equivalent matches on Coursera, along with a relevance score for how similar it is. And then universities can search for specific courses and then see all the Coursera courses that match their contents. And they can actually kind of click out to the individual course pages and then view them. So it's just a way for them to start seeing some of the equivalents we have available that they can then use to serve their students during this time. And to kind of peer under the hood a little bit about how this course match technology works, it's powered by Word2Vec, which is a neural network model that learns what are called vector embeddings for words, basically using the surrounding context in the text. And to get a little bit more specific, here's kind of a little bit of an overview of Word2Vec. So the idea is you have like a paragraph or a piece of text, and that text is composed of individual words. So you can imagine our kind of paragraph of text is this sentence that the Cardinals will win the World Series. And then what we want to do now is we want to turn each one of these words into a vector embedding, or essentially a series of ordered numbers. And so we want to translate text to math, because once we do that, we can then leverage a lot of the great properties about math of like adding, subtracting, comparing things in terms of their numerical values to do really interesting stuff with the text. And so we'll do the neural network word-to-vec model to kind of translate the words to these vectors. And the nice things about these vectors is that they actually capture a lot of the kind of semantic meaning of words. And so can recover lots of different aspects of language within these kind of series of vectors that we would translate each word into. So here are some examples of the kinds of things it can recover. So one would be like male-female relationships. So just how, you know, king is similar to queen because of the fact that man is similar to women. It can capture things like verb tense. So, you know, walking is to walked as swimming is to swam. And then it can also capture a lot of kind of like contextual relationships. So things like country capital pairs, where we know that Spain, the capital of Spain is Madrid, the capital of Italy is Rome, and things like that. And so it's a really great way to kind of boil down the, you know, our understanding of language into a mathematical form that we can then do a lot of really cool things with. And then just to kind of dig a little bit deeper into kind of word-to-vec models. So here's kind of the neural network architecture for how you would train a word-to-vec model. And there's kind of like 4 key steps to go through when you're doing this. So one is that you need a large text data set. And you need a really, really large text data set. So you're thinking of things the size of like all the Wikipedia articles in English, right? And then once you have that large text data set, what you want to do is clean it. So you want to remove really common words, punctuation, capitalization, kind of standardize the text sort of through the normal NLP cleaning processes. And then the second thing is you want to extract the full vocabulary from that cleaned text data. So the set of unique words and phrases. And then what you want to do is identify for each word and phrase in your vocabulary, you kind of want to use the context around that word to then try to transform the word into a vector embedding. And so the way this works is you can imagine kind of a sentence from something like the Bible, where it's like, you know, the Old Testament King James Bible. We're going to use the context around the word king. So words like Old Testament and James and Bible to kind of predict the word king and sort of translate it into a numerical vector. And so kind of once we've done this first 3 steps of kind of assembling what our large text data set is, identifying the unique vocabulary words, and identifying the training data set and our target variable, we then need to actually train this neural network model. And you know, one of the things about this neural network model is because we're trying to get an embedding for every single vocabulary word in our data set, and our data set is a very large thing that's basically, you know, the size of the English language. The training this model can take, you know, hours or even more likely days, and it gets really complicated in terms of maintaining this architecture and kind of going through all the, you know, parameters in the model and trying to actually really fit it well. And so this kind of raises a central question that you always encounter in data science. So the build versus buy decision, or in this case, buy for free, because there's a lot of publicly available sources. But when we were looking to kind of build our, you know, word-to-vec model to power this course match technology, we decided that instead of training our own model, we would leverage pre-trained word vectors out there. So there's a lot of companies that actually used access to the large text data sets that they have. They build these neural network models, and then they have a mapping of each word in their vocabulary to a numerical vector representation. And this saves a ton of time on effort, and it leverages generally state-of-the-art work that's publicly available. So these are, you know, the best researchers in the world who are building these models and this output that you can then take full advantage of. And so I just have a couple examples here. For Google, for example, has pre-trained word embeddings available at this link here. They build it off of Google News. Facebook also has pre-trained word embeddings available that they built off of Wikipedia. And so these are 2 resources that we've leveraged to get these word embeddings that we can then use for our tasks. And the nice thing about these is that both of them can be used directly in Python with GenSim. So, you know, state-of-the-art NLP packages can leverage these pre-trained word embeddings directly. And so now I want to kind of just give a light overview of course match and how it works and how we leverage these pre-trained word embeddings. So to start with 2 things. One is you identify kind of the set of Coursera courses. So we would pull all the Coursera course names that we have on our platform along with the lecture transcripts. So these are, if you watch the videos, these are the words that the instructor will actually say. So we have that sort of stored in our database on a word-by-word basis. And this forms the sort of set of text that we then want to put into our embedding model. And so with the course names and lecture transcripts, we extract the individual vocabulary words, and then we kind of pull the embeddings that map to each of those vocabulary words that occur in the lecture transcripts and the course names. And then we'll have, a series of words and vectors for our Coursera courses. And then we can average the word embeddings to get a vector at the course level. And this vector at the course level sort of captures something about the meaning and subject area and sort of skills and all these other aspects taught in the course. And then we do the same thing with the university courses. So we take the university course names, university course descriptions, and even university syllabi when we do have them. And then we again extract the individual vocabulary words, and then we kind of pull the embeddings for those individual vocabulary words. And then we average all those together to get a university course level embedding. And then what we have now is a list of Coursera courses and their embeddings, and a list of university courses and their embeddings. And then we can kind of compute all pairwise similarities to identify, which Coursera course is the closest equivalent to each university course using this, cosine similarity measure that you can kind of use for numerical vectors here. And so the great thing is it's like pretty easy as we continually get new university courses from the partners we work with or from people who are interested in using the platform. As we continuously launch new courses on Coursera, they can automatically feed into this system. And then as a result, we're always sort of able to match the latest set of university courses that we have knowledge of to the latest set of Coursera courses that are available on our platform. And then we can give these as recommendations to people who are trying to push online and serve students in this time or even in the future who want to just leverage Coursera to supplement their on-campus offerings. And, we've been really humbled by kind of the uptake and sort of widespread acknowledgement of this technology that's been out there. Here are just a couple of the news organizations that have talked about this algorithm. We've had a lot of inbound requests from people sort of looking to support their on-campus students in their transition online. And so we're just really excited to continue to leverage this technology to support them. And I just want to kind of close with a couple of high-level findings and some things that we've learned while doing this process. I think the first main tip is that wherever possible, leverage open source word embeddings. So, Google News, Facebook, Wikipedia, all have publicly available offerings, and, leverage open source packages like GenSim to start quick. You don't need to always train your own model. You can leverage the state of the art work out there for your use case. And then two, one thing we found that was really powerful was building a general embedding infrastructure. So building a general database of this, word to vector embedding data sets that any data scientist at Coursera can draw upon, because this really powers a lot of downstream applications and allows people to come up with new applications that you may not have thought of before. And then third is like anything when you're thinking about giving recommendations to people, this can greatly benefit from embeddings, because you can think about sort of transforming whatever recommendations you want to the embedding space, and then using the math of vectors to kind of think about how to calculate similarity and sort of find the closest equivalent product that you offer to what people are asking for out there. And yeah, thanks everyone for letting me share our course match technology with you. And feel free to reach out to me over email or at LinkedIn. And if you're interested in learning more about Coursera's work, we have a data blog that you can see here.
Great, thanks for that, Vinod. We've got a couple of questions that came in during your talk. So Ari asked, how do you evaluate the accuracy of the model?
Yeah, so this is a little bit where there's not like a great automatic way to do it. And so it's a lot of kind of looking at the results and figuring out, okay, there's like a finance course at the, that we're trying to match to on the university side. Does our Coursera content sort of return similar finance courses that conceptually make sense? The other thing we can do is we can look at in our own catalog, do we tend to group similar courses together? So at Coursera, we have what we call subject areas. So we have like business, arts and humanities, English, and we can see whether those groupings are recovered by the course match sort of similarities. But it's a lot of just kind of like deep looking at the data to figure out if it looks right.
Great. And Gordon wanted to know, one of the initial models that you mentioned, is that like the Ngram model, which goes both forward and backwards?
Yeah, so Ngram is like kind of like a, a sort of more basic version of doing this kind of similarity scoring. And neural networks are just kind of like a next level of doing that, where you can kind of capture even more relationships between text and sort of handle larger size data sets.
Sure. And kind of to open it up, the sort of general Q&A with some of the pre-submitted questions. Somebody had asked what sort of policy and privacy sort of constraints you guys have been subject to when developing models using data. So maybe, Sergey, you want to start off with that?
Sorry, start off with what?
One of the pre-submitted questions just asked if any of our speakers have faced any policy or privacy constraints when sort of developing models or using data.
Well, we take privacy very seriously. Like you might have seen, I pixelated some stuff in my presentation. That's because there's a remote chance that could be personally identifiable. Mm-hmm. But yeah, we basically don't take chances. And there's no constraints insofar as we train models on an aggregated, unidentifiable basis. So like we use user data to train models, but we only use user data in an aggregated way, and the model cannot be used to derive the user data back from it. And if the user deletes their data, then we will retrain the model without it. Because of federal regulations in the United States, the school must always be in control of their data, not us as the school official. Mm-hmm. We're called the school official according to the regulations. But anyway, if they want to delete their data, then we absolutely actually delete it, not just mark it as deleted, and we'll retrain the models, not including that data.
Sure. Another one that came in, maybe Kian, you could take this. Somebody asked if you're from an educational background with no real sort of technical AI knowledge, what do you think, how can they possibly decide whether AI is the right sort of route to be investing in for them?
Yeah. Actually, is the question on the list so I can read it as well, or?
No, so it was one of the pre-submitted ones. They asked, where is it again? How
okay.
Can your institutions decide?
Yeah, then. Okay, then I'd say that, following an AI career is not always the right path, not for everyone. It's a specific job that you have to like and fit for. I'd say that in terms of skills, you'd be looking at foundational skills in science and engineering. Science includes mathematics, probabilities, statistics, mathematics with linear algebra, functional analysis, and calculus. So you have to like doing all of those in order to go for a data scientist route. For a machine learning engineer route, you would add lots of software engineering aspects of the work and algorithmic aspects. I think that lots of jobs are going to be created in the coming years in the field of AI. Those jobs are not all machine learning engineers and data scientists. There are tons of companies that now are figuring out that there is such thing as a data science consultant that is public face, that is client facing. Other companies are finding data engineers most efficient in order to augment the productivity of the entire team with fewer data scientists and machine learning engineers and more data engineers. I think that there are several career tracks. It all depends if you like science, you like engineering, and you like solving technology problems. I wouldn't compare the job of an AI person to a marketing or sales individual that is more client facing and interacts more with business.
Sure. And then another that was pre-submitted, maybe Vinod, you could take this one. Just touching on how we can ensure accessibility at scale with some of the sort of educational models that are being seen in the market at the moment.
Yeah, I mean, I think there's a lot about thinking of, so I think when you think about education, the difficult thing is everyone wants to access education. And so the types of people that access it is so diverse. And so when you think about trying to scale education, it's really about handling the large amount of diversity and kind of all the different, edge cases and subgroups that come up. And so, I mean, part of it is having a diverse workforce that can sort of be more familiar with some of these different groups that might try to be access education, but it's also thinking really deeply about how your product is going to be used, the end customers you're going to be serviced, what are their pain points, and then doing the user testing, getting the feedback, and then incorporating that into the development cycle of additional iterations that you do in your models and your work. Okay, brilliant. And a question I quite like to ask in all the sort of webinars that we've been running recently, what are you guys most looking forward to project-wise working on in the coming months and sort of the rest of 2020? Sergey, do you want us to start?
Well, the work I presented is mostly ongoing, so I just look forward to making more headway on that. And that is basically speeding up grading further by sorting short answers according to similarity to each other. Yeah, that's really the biggest one. I mean, we like to tackle things in the order that they impact users. Mm-hmm. And short answers are clearly like the most popular question type that we don't currently assist with. So that's really the next one for us.
Sure. And Kian, yourself?
Could you repeat the question, please? I disconnected.
Absolutely. We're just asking what you're most looking forward to working on sort of in the coming months and for the rest of 2020 in your own work.
I think that due to the significant number of layoffs due to COVID, what I'm excited to work on right now is to expand the number of job opportunities for our community, and try to help everyone find the job they like and find the next step in their career. That's what I'd be focusing on.
Brilliant. And Vinod, yourself?
Yeah, kind of similar to what Kian was saying, like lots of people are sort of having their education disrupted, sort of looking for new jobs. And so Coursera, we've sort of started a bunch of initiatives sort of targeting these different groups. So initiatives for unemployed people, initiatives for universities and campuses, initiatives for governments. And so just thinking about how to scale those around the world and sort of support our end users even more.
Sure. And I gather we've gone slightly over time-wise, so kind of wanted to wrap things up. I know you guys have put your contact details in your slides there, so obviously people can get in touch with you either through email or via LinkedIn if they have any further questions. But again, I just wanted to say thank you for your time this evening. Obviously this has been recorded, so we'll send it over to you guys first, but then get it out to the wider audience. Yeah, thanks for joining us. Really enjoyed your presentations, and yeah, everyone attending, connect with them on LinkedIn and get your questions across that way as well.
Yeah, thank you.
Great. Thanks, guys.
So, thank you.
Have a good evening.
Bye-bye.